Hey everybody, welcome back to Chapter 8, Section 2. Here I'm doing more domain and range and asymptotes of rational functions, and then I'm going to talk to you a little bit about transformations. So this first one here, I'm going to go ahead and I'm going to identify my vertical and horizontal asymptotes. So this should feel a lot like the other video on Chapter 8, Section 2. So your vertical asymptote, you just set that bottom equal to 0, the denominator. And so that would make it -3. -3 plus 3 would equal 0. So my vertical asymptote is at x equals -3. And so my domain is just going to be x's in all real numbers such that x equals -3. And then I'm going to move on to my range now, and my horizontal asymptote. That's just going to be that number on the side. So I'm going to say horizontal asymptote. And now we're in y equals -4. And so that's going to influence my range by just being you can't equal to that. So y is in all real numbers such that y cannot equal the asymptote. The reason why you can't equal the asymptote is because an asymptote is an imaginary line that you cannot touch. It'll be undefined at those points on the graph. So now we need to identify our transformations. Here I have a negative, and so that means I'm going to have an x-axis reflection with that negative. So I'll put x-axis reflect. Okay, and then that +3 is technically on the inside. And see how it made your vertical asymptote go to -3? That means it moved left 3, right? If it's on the x-axis, it can only move left or right. So I'm going to say left 3. And then my horizontal asymptote was at -4. So that means it moved down -4. Remember, if you add or subtract on the outside, it goes down. So I'll just put down 4. And those are the transformations for that one right there. So for this one, I have a vertical asymptote at x equals +2. Because if you set that denominator equal to 0, 2 minus 2 would make 0. So then I just like to move straight to the domain. And so my domain is x is going to be in all real numbers. So you have to put that kind of bracket, then an x. That line stands for such that. So it's basically a condition. So x is in all real numbers such that x cannot equal 2. And then I'll move on to my horizontal asymptote. And so that means my horizontal asymptote is just going to be at y equals 1, which means my range is going to be simply y is in all real numbers such that y cannot equal 1. And so I don't have any other negatives. There's no reflections here. I had two transformations. That -2 is on the inside. If it's on the denominator of the fraction, it's counted as the inside. So that means that's going to go right 2. And then that +1 was on the outside, so that means it's going to go up 1. And then look, your horizontal asymptote was at +1. So right 2 and up 1 are your transformations. So this last one's not any more difficult. I just made it with all decimals. It's still the same idea. Set your denominator equal to 0. Your vertical asymptote would be at +2.2, meaning your domain is x is in all real numbers such that x cannot equal 2.2. All right. My range in horizontal asymptote is going to be influenced by this number. The horizontal asymptote is at y equals -6.1. So my range is y is in all real numbers, but y cannot equal -6.1. So my transformations are, it was at +2.2 for the vertical asymptote, so it went right 2.2. Because remember, if it minuses something on the inside, that's like it's going right. If it plus something on the inside, it means it goes left. So this was right 2.2. And then your horizontal asymptote was down 6.1 because it minus that 6.1 on the outside. And that's everything you need to know for this first section. So for this next section, your domain and range, well, your types of problems are going to have an x on top and on bottom. So to figure out your domain and range, we'll continue to set the denominator equal to 0, but for the range and the horizontal asymptote, you're going to do this, y equals a over c. Where am I getting a over c from? If you write it like this, ax plus b over some cx plus d, it's basically just the coefficients of a and c. So it'll look like this. I have 2x plus 1 over 3x minus 3, so I'm going to do my vertical asymptote first. So vertical asymptote is set the denominator equal to 0, so 3x minus 3 equals 0. So I can add 3 to the other side, and then the only way to split up a number by a letter is by dividing it, and so I'll divide that. And 3 divided by 3 is 1, so x equals 1. That's my vertical asymptote. So my domain is simply x is in all real numbers such that x cannot equal 1. So now for the range, I'm going to do this. I'm going to take the 2 by the x and the 3 by the x and divide them. Oh yeah, but before I do the range, I have to do horizontal asymptote, don't I? So I just say y equals 2 over 3. That's it. So my range is y is in all real numbers such that y cannot equal 2 over 3. So yeah, it's a pretty simple formula, but that's just how your asymptotes are made on the horizontal ones. It's if there's an x on top and bottom, just divide those leading coefficients. So for this g of x example, I'm going to take 6x plus 2, and I'm going to set that equal to 0. And so I can minus 2 to both sides, and then I have 6x equals negative 2, and then I can divide by 6, and I get x equals negative 2 over 6 makes negative 1/3, and that is my vertical asymptote. So that means my domain is x is in all real numbers such that x cannot equal negative 1 over 3. So now let's move on to our horizontal asymptote. So our coefficients are 3 and 6. So my horizontal asymptote is simply y equals 3 over 6. That can be simplified to 1 over 2. 3 is half of 6. So that's my horizontal asymptote. And so that means my range is y is in all real numbers, except y cannot equal 1 over 2. And that is everything on that one. So for this example, I have 8x minus 1 over 4x plus 2. So I'm going to take my vertical asymptote, and I'm going to say, what is 4x plus 2 equals 0? Did I say 4x minus 2 earlier? I don't know. I'm not going to play this back. So let's solve for x. Minus 2, 4x equals negative 2. So then I can divide by 4. And negative 2 over 4 simplifies to negative 1 over 2. So that is my vertical asymptote right there. And then my domain is simply x is in all real numbers such that x cannot equal negative 1 over 2. Okay? And then for my horizontal asymptote, look at your coefficients by the x, 8 over 4. And so horizontal asymptote is y equals 8 over 4. And 8 divided by 4 makes 2, so if it simplifies, definitely simplify it. So there's my horizontal asymptote, which means my range is just y is in all real numbers such that y can equal 2. And that's pretty much everything there is to say about that one. So in this section, what do you do if there's an x on top and on bottom, and there's a number adding or subtracting on the side? The key is to continue to set the denominator equal to 0 to figure out your domain. For the range part, just take the a over c and then combine it with the k. So let's see what that'll look like in these 3 examples here. So I have 2x minus 1 over 4x plus 3. So my vertical asymptote is just going to use that 4x plus 3. And then I'll write equals 0. And so I can minus 3 to the other side. And I get 4x equals negative 3. So then I can divide by 4. And so I get x equals negative 3 over 4. And that's my vertical asymptote. So my domain is going to be x's in all real numbers. Oh, don't forget your bracket. Let me just erase this. I needed to write the D for domain. X is in all real numbers such that x cannot equal negative 3 over 4. So my horizontal asymptote, so that was that. I forgot to circle it. My horizontal asymptote is going to use the 2 over 4 plus 6. So I'm going to say horizontal asymptote is HA is y equals 2 over 4 plus 6. So 2 over 4 simplifies to 1 over 2, and if you add 6 to that, you get 13 over 2. Okay? You could get it as a decimal if you want and say 6.5, but generally speaking, I kind of prefer fractions over decimals, but it's really not that big of a deal. So my horizontal asymptote is at y equals 13 over 2, so my range is just going to be y is in all real numbers such that y cannot equal 13 over 2. So that's literally all we had to do is just combine those. If this were a minus 6, I would have put a minus 6 there. I'm not flipping any signs or anything. So on this one, I'm going to start with setting the denominator equal to 0 for my vertical asymptote. So I have 2x minus 10 equals 0. So I can add 10 to the other side. And I get 2x equals positive 10. And so then I can divide by 2. And I'll get x equals 5. That is my vertical asymptote. So my domain is x is in all real numbers such that x cannot equal 5. And so then for my horizontal asymptote and range, I take that 8 over 2 and then I combine it with the minus 4. So I'll say HA is y equals 8 over 2 minus 4. Well, 8 divided by 2 is 4, and 4 minus 4 is 0. So I'm just going to say y equals 0. And so if that's my horizontal asymptote, then my range is y is in all real numbers such that y cannot equal 0. All right, so hopefully you feel like you're getting the hang of this. I'm going to do one more example. So here I have negative 5x plus 3 on the bottom, the denominator. So I'll set that equal to 0. And so that means, whoa, I wrote 0 equals. That's weird. I'll minus 3. And so I have negative 5x equals negative 3. And so I'll divide by negative 5. And so I'll get x equals, the two negatives cancel out to get positive 3 over 5, and that is my vertical asymptote. So that means my domain is simply x is in all real numbers such that x cannot equal that vertical asymptote value of 3 over 5. So my range in horizontal asymptote, I'm going to use the 2 over negative 5, and then I'm going to use the plus 8. So I'm going to say horizontal asymptote is y equals 2 over negative 5 plus 8. So type that into your calculator. Your calculator is going to tell you 38 over 5. So y equals 38 over 5. That's my horizontal asymptote. That means my range is y is in all real numbers such that y cannot equal 38 over 5. So with that, I'll close the notes. Thank you for watching. Like, comment, and subscribe if you feel like it. Goodbye.